Hello friends, welcome back to another video on VROS. Today I want to talk about what's probably the single most important thing of this prototype, which is the windows. How they behave, how I interact with them, how they move, and also how I implemented them so that they would be displayed in a satisfying way, which, spoiler alert, was trickier than I thought. Now, this is going to be a pretty long video. If you want to skip forward to essentially the most interesting innovation part at the very end, you can just check the description for a timestamp that's going to let you skip forward to that specific spot. If you're interested in getting all the nerdy details on how and why I chose to make these windows in the first place, how they move, how I can interact with them, and then also some of the problems that came from making these flat windows in 3D space and how I solve those problems, you can stick around and I'll take you through my thought process one step at a time. So I'm going to jump over my motivation for having 2D windows in this VR space in the first place. I believe it's important to still be able to display flat content, whether or not you are in a 3D immersive environment. So let's just skip over that part and let's start talking about why things look the way they do in here. First of all, I want to talk about the size of these windows. Because I did get a lot of questions about whether or not the content in here was actually big enough so I could read it. And yes and no, in a way. Because no, the content is not big enough so that I could read it. I cannot read these emails here. I cannot recognize these icons. I can barely read this headline here. But that doesn't have anything to do with the size of the content in here. This is more of a problem of the head-mounted display that I'm wearing in the first place. Head-mounted displays today have very low resolution, and so even content that's displayed at a reasonable, realistic size is not really readable. That's why you don't see a lot of applications for productivity of VR headsets right now, other than the fact that they're not very comfortable to wear. Let me explain to you why I chose to make the content the size that I did anyway, though. Here I have a rectangle that's the size of a 13-inch laptop monitor and a rectangle that's the size of a 28-inch desktop monitor. These are literally the monitors that I have in front of me on my desk right now. They're positioned more or less like this. My desktop monitor right in front of me and my laptop monitor kind of a little bit below that. Now, to get the size of these right, I did something very unscientific, which was basically just take off the HMD, look at the monitors in the physical space, put on the HMD again, adjust the size, take it off, put it on again, etc., until the size of these were pretty much correct. And so they became my reference point for how big all the other content should be. Because, for example, my email window here that I'm using every day on my laptop, I could just place that here on this, laptop monitor rectangle and see that, all right, this is an actually realistically sized representation of my emails. Right? I know that if I was to take off my HMD right now, my email window would be the same exact size, meaning if the HMD had high enough resolution to actually display this text, I could actually read it. It wouldn't be too small, and it's not unnecessarily big. Same thing with this blog post in a browser window or this photo. If I move these to this 28-inch monitor rectangle, I can see that, they're filling up the space pretty quickly. This is definitely how I would expect my content to look on a big monitor in front of me. So that pretty much settles why things are the size that they are. Even though I cannot read any of the details of the content here, that's not that important for me because this prototype is really focusing on interactions and interface and learning what workflows might start looking like once we have a system like this. Some, many years in the future, maybe 3, maybe 5, maybe 10, whenever HMDs might become comfortable and good enough to be useful for these types of use cases. Okay, so we have size. Now let's talk about how these windows move in space. Because you can see that if you're using here this interface element around me that I'm calling the bridge, if you're using that as a reference, you can see that as I move the windows around, they also move similarly. As the bridge curves around me, the windows also move on this curved trajectory. It's essentially a circle. If I just go horizontally, it also is a circle when I go vertically. And if you combine these two, it basically means these windows are moving on this spherical shape around me. Now, and this is not just a coincidence, because going back to some of the constraints and criteria that I set for myself early on as I was working on this prototype, once I knew that I was going to have 2D windows that should behave reasonably similarly to windows on computers today, I knew that the windows were going to have to do some things. First of all, I knew that no matter where I was going to place a window, the window should just keep looking the same. Meaning, just because I'm moving a window from dead center in front of me to somewhere on the size, I didn't want the window to suddenly shrink in size. It shouldn't just move further away from me. Because there's not really a strong reason for why a window should, just change just based on the position where I put it. If I want to rearrange my workspace and make sure that I have some things over here on the side and have this thing here in the center, there's no reason why suddenly I should be less able to, for example, read my emails just because they're over here, right? So as the windows are moving around me, they keep the same distance to me, meaning their movement will always be either circular or, spherical in 3D space. Now they're also always facing me. And this again comes back to, well, the constraint of I want a window to be useful no matter where I put it. A 2D piece of content that doesn't face me is not really as useful, because the information presented in the window is always going to be best when it looks straight at me. And if you combine these two behaviors, these two constraints, then this is the resulting motion that you get. Every window moves around me at a fixed distance and keeps rotating towards me no matter where I put it. And yes, the resulting behavior is, you could argue, kind of conservative. Some people said to me, well, but you're just taking essentially what's a really big curved screen, you're curving it all around you, and that's what you're moving the windows on. Why aren't you using the entire space, all that potential that VR has to offer? Why aren't you using that more? Why aren't you moving windows off into the environment? Why don't you have more complex geometry that's more similar to maybe a physical office, with a surface as a tabletop, with walls around you that are standing up and that you can organize your windows on? And I want to take you to another scene here and show you why I don't think that's necessarily the best solution when working with this kind of content. So here I took 3 copies of the same window and I just progressively moved them further and further over to the side. So you could really see how, starting with something here in front of me, as I move it further over and further over, it just curves around essentially. The windows keep facing me individually so that I can always look at each window and it pretty much looks the same to me wherever it is positioned. Now I did hide a few additional windows back here, and I want to show you what happens to the same windows when they don't have this behavior that I just described right now. Let me take this one away. And you can see that behind it is a window that is actually on the same plane as this window. So these are sitting on the same flat plane. It's only that in this case, by moving this window over to here, I'm really just moving it sideways. It's not circling around me. So it's just moving a little bit further into the distance, and it is already feeling significantly less facing towards me than this one. And now check out what happens when I take this one away. There's another one behind it. And just look at how incredibly far away this already feels compared to this one. Right? This is already so far in the distance, and it feels like it's facing some random point somewhere over there, and it becomes less and less useful to me. Not only does the content become smaller just because I'm moving it further to the right. Now, if I take this window here and I put it side by side with this third one over here, you can see this crazy size difference, the perceived size for me, between this window and this one. I can overlap these two, and you can see that this starts out as the same exact window. And I just move that further over to the side and further over to the side. And no matter how far I go, and no matter how many windows I might be arranging in my workspace, wherever I place this, it still feels and looks like the original window. This one doesn't at all. It's small, it's distorted because of perspective foreshortening. This would be extremely hard to work in if it was some sort of graphic that I need to edit, some sort of plan drawing that I need to measure things in, etc. Anything that I need to do pixel perfect, or where straight lines just need to be represented straight. But if you think about it, this is the behavior. So these three windows, they're representative of the behavior that you would have if you said, oh, I'm just going to have one large flat wall in front of me. Right? The moment you're working with a flat surface, this is what your windows are going to do. And I don't know why I would ever want to have this behavior rather than this behavior. And this is really the gist for why I believe that this type of movement for Windows, for 2D Windows, is really the best one. Things definitely change when we're talking about 3D content that you want to be able to look at from different sides, larger pieces of 3D content where it's important that things move into the distance. But as long as I'm talking 2D content in simple rectangular windows, I want those windows to just look as simple and as straightforward as possible. All right, now we're back in the scene from before. Now I have talked about the size of the windows and the behavior of the windows. The behavior of the windows, of course, also defines what some of the environment looks like. Like the bridge is circular because of the movement of the windows, and it just makes sense that it matches up with them. Right? If I'm moving my windows around the space here, I want to be able to drag something in the bridge easily from any point around the bridge. And then I want to make sure that my windows can still move at in a similar way inside the bridge. Now let me talk about some of the problems that come from having the windows behave the way they do. Because as I'm interacting with these windows, you can really tell that I have no restrictions on where I can move the windows, how they can overlap. I can basically go all the way behind me, can go pretty much above me. Oops, why does that not work? Yeah, can go above me. So I can pretty much do whatever I want as if this was a really big monitor. And this really helps people pick up the system and just start using it. They have a mouse that feels like a normal mouse pretty much, and then they can grab any window and move it around as if it was just a really big monitor. Now, because I'm making sure that it feels as flexible and as accessible as a desktop operating system today, it comes with a couple of problematic issues when looking at how these flat 2D objects interact with each other when you move them through space. Let me close these here and let me focus on these two windows for a second. Now, when I move them right on top of each other, totally centered in front of me, it makes sense that these are just flat windows that are sitting on the same plane, right? They're just sitting on the same flat plane here. There's no strange overlaps or anything. This is really just like showing two windows on a flat monitor today. If I can use my hands to explain this a little bit further, this is kind of a clunky way of doing it, but this is my best way of showing my hands really. Now you have one window that sits like this and one window that sits like this, right? They're right in front of each other. They're both completely facing me and they're flat. Now, when I take this window and move it over to the right, and I take this window and move it over to the left, what happens is that they're both individually rotating because they always want to face me. And so the one on the right goes from this position to this position, and the one on the left goes like this, right? So now I have two windows, one like that and one like that. I'm exaggerating the angles here, but that doesn't matter. Now, there's no inherent problem with that as long as the windows are staying kind of nicely separate from each other, right? All the way to here, there's no issue. Just move that a bit higher up so that these line up more nicely. So now I'm looking at one window like this and one window like this, and they're getting really close to each other. Now, what happens when I do this? Right? You don't think about this twice on a flat monitor because you're just moving windows like this, right? And so one window can be in front of the other depending on which window is in focus. No problem. Now though, these windows, they're still individually rotated in space, right? They're still not at a perfectly parallel angle here. You basically take these two windows, and what I did is I made them intersect like this. It looks to you right now when I look at this, it looks like they go like that, but really geometrically they go like this because they're all moving on the same at the same exact distance from me. One is not in front of the other. They go like that. But why does it not look like they're actually intersecting? Why can I just see this complete window here? And why can I see this complete window here when I bring it into focus? And that's actually the big problem. And the reason why it looks fine right now is because of the solution that I came up with. To explain this a bit further, I prepared another scene where I have a few example windows that look pretty much the same, but they are all rendered in different ways to solve this problem. So to explain the problem in the first place, I'm just going to look at this here. You can ignore these black borders. That's just a rendering error on my end here. But essentially what I'm looking at is the same condition that I just had with these two windows earlier. They're two individual windows, and they are both rotated in a way that they face me, meaning that they're not at a parallel, their surfaces are not parallel, and they are basically at an arbitrary angle. And the moment, in this case, I'm looking at these two windows over here, and I have one that's like this and one that's like this, and one part of the window of the two windows is basically overlapping. And here, because I didn't apply any type of rendering trick, here you can really see how these intersect. And this is obviously not an acceptable way of doing work with windows on a computer. Now, as long as you only have two windows, you could argue, well, just don't make them overlap. Sure. But as I showed you before, one of my really important criteria early on was that the movement of the windows needed to feel really natural. I needed to be able to just pick any window up and arrange my workspace however I wanted to, not however I was limited to because of the implementation constraints of the prototype that I built. It's not good enough to just have windows sit side by side. I want to be able to freely move them around all over the place. So this condition was going to happen all the time. I was constantly going to have windows slice through each other, windows occluding parts of other windows, etc. And in this case here, there's almost no way that I could look at this entire window, right? It's just natural physics, essentially, that this window eventually slices through this window and disappears behind it. But you can see that I have two other options here. This one is the first quick stab that I took, which is not an ideal solution, which I'm going to explain in a second. And then this is my final solution, which also just looks like, I mean, they pretty much look the same, but they work in very different ways. Now, I'm actually going to leave the immersive environment and I'm going to go into Unity, the program that I used to build this prototype, where I'm going to be able to look at the scene from all kinds of different perspectives. Okay, now this is Unity. This is the scene view where I can, even though the prototype is currently running, I can have a look at it from all kinds of different angles if I want to. Now you can see that this is live because you can still see my hands down here on the keyboard, and you can actually also see this is my head this is the HMD. It's currently not on my head. It's sitting on my forehead so that I can see my desktop monitor here. But essentially, this little cube here, that's the back of my head. And then these cameras are what I'm seeing the immersive environment through when I am actually in VR. Now, here's another quick look at this first example that I showed you. Right? You can see. Sorry, now I'm on a different mic, so I gotta make sure that I'm actually talking into it. You can see these two windows. It's pretty simple stuff. These are really just totally flat. And I can rotate this around to show you how they intersect in the back, how one pierces through the other. And I can show you how just moving one kind of more forward, decreases the amount of overlap. I can move it further back to increase how much it's overlapped by the other window. And so, yeah, this is just a very natural thing to happen when you have two flat objects that are getting really close to each other in 3D space. Now, let's move on to the second option here. This is the one that I used as the first quick fix, essentially. The technique that this is based on is basically playing with what's called the render queue of the 3D environment. That means every frame that the prototype renders for my eyes to see, I'm basically just telling it to render this window. Sorry, my mouse cursor. I'm telling it to render this window here. I'm telling it to render this last. Okay, so the prototype renders the stuff in the background, the environment, the bridge here, my input devices, etc. It renders this window, everything, and then it renders this window last, which means that it is on top, it is visible on top of everything else to my eyes. Even if this window was miles back, it would still render on top. That means when I now rotate this around, for which I'm just going to center the UI here quickly. So when I rotate this around, you're going to see how, again, the placement of these windows is the same as the placement of these windows over here. If I wasn't applying this rendering technique, this window would be sliced off here the same way as over to the left. Now you can see how unnatural it looks when I rotate this around, and we can clearly see how the window that's actually behind is still being rendered in front of this other window. Right, so this section, this corner here of the picture with the kitchen, that should be behind the window with the search results. And as I rotate this around, if you keep looking at this corner, you can see how oddly this corner kind of behaves, how strange and unnatural its motion is. So again, I can bring this to very extreme perspectives here to show how odd it is that this window is rendering on top of the other one. Now, for you on a 2D video recording, this might look fine as long as, it's not in too much motion, or as long as I'm not looking at this from very extreme angles, which arguably I wouldn't anyway. When I'm using the operating system, I'm mostly looking at the windows from the front anyway, right? But the problem is that inside of an HMD, you're looking at this content with stereo vision, and your brain and your eyes will pick up very much on depth information in here, meaning that a point that's further away, your eyes will be able to understand that that's further away, even in virtual space, and something that's closer by will feel closer by to you, whether or not it is bigger or smaller in size. Now, this is the issue that arises now here in this corner. Because this corner is technically, if we're really accurate about it, this corner is behind this window here. It's only through an unnatural trick that I'm rendering it as if it was in front. So when I'm looking at this corner here, my eyes see something. They have to converge on something that's actually further away than these points here. But to my brain, instinctively, it feels like, well, but this corner is in front of this window. Otherwise, I wouldn't see it. So what your eyes see and what your brain thinks it's going to see before your eyes have converged on it is something different. Meaning that you keep on looking at different parts of this window, and your eyes have to do all this surprising work converging at different depths than they think certain points should actually be. When you're wearing an HMD, as I was wearing before, this corner looks almost like an optical illusion that's kind of flip-flopping on you. Because my eyes keep going from these points here to the surrounding points. My eyes have to go back and forth between the points here and the points here, and they can tell that there is a depth conflict happening. Over time, this is really uncomfortable. Even just after a minute of looking at this corner here, it feels like it's flickering. It's really not nice. So while on a 2D video, this might look like an acceptable solution, again, as long as things are pretty much static, it is not at all an acceptable solution, especially once we're talking about, you have 5 windows on the screen, you might have 10 windows on the screen, multiple windows might be overlapping in different positions, and now your eyes are just dancing around and losing complete any type of orientation for what's in front, what's behind, etc. And that brings me to the solution, and that brings me to the custom solution I came up with for my prototype. Now, welcome back to the people who skipped over the rest of the video to get right to this point. You might be missing a little bit of context, but you can just backtrack to the rest of the video. But basically what we're looking at now is my custom rendering method for windows that appear perfectly rectangular and flat, but that avoid problematic depth conflicts from intersection of these flat objects in 3D space. So while these windows look pretty much perfectly rectangular right now, the moment I leave the point of view that I would usually look at them from inside the operating system, the moment I rotate the scene around now, you'll see that the windows are anything but flat. You can see that the windows curve both around this way and this way. Essentially, what's happening is I'm taking rectangular windows that are totally flat, that are still positioned at their correct place in space, and I'm pushing them. I'm pushing all of their content. Every point on these windows is pushed against the inside surface of a sphere, meaning the result is that all of these points are actually sitting on a continuous surface, completely avoiding any type of situation where one point might be hiding behind another window or something occluding something that I actually would want to look at. The windows still look like they are somewhat arbitrarily rotated in space so that they can still individually face me as straight as possible, meaning that I can still look at their content in an as undistorted way as possible. But they're essentially projected from the position of my virtual eyes onto this inside surface of the sphere, meaning that to me, they still look perfectly undistorted, but for an outside observer, they look totally curved. Now, the result of this is, yes, all of the points that you see on both of these windows, they're at the same distance from me, because the sphere that I'm projecting onto on the inside, its center is also where my eyes are positioned. So all of these points are the same distance from me, meaning my eyes have to do very, very little work to reconverge on different points as I'm looking around these windows. Now, technically, that's unnatural, right? A flat object that's facing me perfectly, I would assume that its center point is closest to me and that its corners are further away from me. And my eyes might expect to having to do reconvergence work when looking around the window. But from my tests inside this prototype, which I've now been experimenting on for the better part of 2 years, I have not felt significant or even any discomfort from the fact that these windows are actually almost in a way to my eyes feel a lot flatter than they really are. One thing that I want to point out about this though is this is not the same as having a curved screen sitting on your desk right now, or I guess a screen that curves around 2 axes, because, and now I'm going to actually take off, let me just see where I'm going to rotate this to. So I'm going to position this window so you can see at the same time, you can see over here, again, this is my head with the HMD. Now I'm lifting the HMD above my head. And now you can see over here are the windows. And just look at what happens to the windows as I'm moving around the HMD in a very exaggerated way. These windows are constantly shifting in shape. But the thing is, they're only shifting in shape to the person who is not looking at them through the eyes of the HMD. They're only shifting in shape to the outside observer. And that's because to the person wearing the HMD, The windows want to stay looking perfectly undistorted and rectangular and flat. And the result of that has to be that their geometry is recalculated every single time the position of the observer changes. Again, though, the result is that I have windows that just look normal and stable without the problem of them having some sort of occlusion issues because their flat geometry would naturally, slice into each other. Now let me take you back inside the immersive environment so you can have one more look at these windows from the point of view of the HMD. All right, awesome. Back inside, you can see here again the 3 examples, this one being the last one that I just showed. You can see no matter how much I'm moving around my head or looking at this from different angles or trying to twist or tilt my head, or however I'm moving these windows around, they always look rectangular to me. You saw how much they are actually changing in size, not size, but shape. But really, to me, they just appear as if they were totally normal windows. And this is the cool thing about this solution. To the user, nothing special happens. They just use windows, they're moving them around, they can prioritize which one they want to see in front or behind. But at the same time, the windows still look natural to the 3D space. This window still looks to me like it's rotated in 3D space in a different way than this window, so that both of them would face me individually perfectly. But my eyes don't have to have any surprising depth conflict situations where naturally the geometry of these windows would actually overlap or basically intersect. And yeah, I can just go about my day and not think about this twice. There's a small issue that I really don't like about this. If you focus on this corner up here again, let me just line this up so it's easier to see. So this corner over here, now when I move my head sideways, you can see how this corner is still moving around in kind of a strange way. It's almost like the parallax between these 2 windows is inverted at this point. And it is, because the way these windows are drawn, they still use the original flat rectangular windows in 3D space as their reference point, meaning that this point is still actually behind this window before this whole kind of shape transformation happens. So now when I move my head around and I get a parallax effect between this corner and the content behind it, it creates this inverted parallax effect. Don't love it. No clue how I would solve that. That's maybe for another 2-month exploration. But yeah, so these are all the details I could come up with that I wanted to talk about in regards to rendering 2D content, 2D windows, flat content essentially in an immersive environment. I believe that if you want to make meaningful 2D content available that can freely move around in an immersive space, you will eventually run into this problem. So I thought it was a really important one to document. It doesn't become apparent from just looking at the other videos that I made from the prototypes. That's why I wanted to do a real deep dive into this one. I would find it a shame if this information just got lost along the way. I'd love to see people build on this idea, make it a lot better, or just, take it as the first stepping stone, because I don't know how far this could actually take you. For me, for my prototype, this was absolutely enough. where the other solutions, or I mean the other issues that I was displaying here, would not have resulted in a satisfying experience whatsoever. If you watched the whole video, thanks for sticking around. Even if you just skipped to the end, it was ended up being long enough anyway, I guess. Yeah, thank you so much for watching. This was really fun. I'm planning to make a few more of these, so stick around and subscribe. Keep an eye on my channel. See you in the next one.